Okay. Alright, I'm starting up the stream. We're going to get started here in a second. Alright, we have actually quite a few more things to cover. So this is a pretty dense class in terms of activity. The good news about this class is it's supposed to be, a Monday, Tuesday class, so we get more time to go in depth into all of these things. So hopefully it gives you all more time to like cement the concepts a little bit. Okay, so we just did arrow functions. Let me go ahead and go to the next activity. Alright, it's not that one. 109. Oh, what? Hold on, sorry. I am pulling up the activity, I swear. Okay. So we're going to look at another cool feature of ES6 called object destructuring and array destructuring, which is a pretty powerful feature. Okay. I'm going to rewrite these as constants as we go too. So normally when we're using objects in JavaScript, what we have to do when we want to reference a property is we'll have to type like object name, so the variable name for the object dot property name. Well, sometimes that's a lot of work. It's pretty verbose. I mean, you're typing the same thing over and over and over again, which is kind of a bummer. But ES6 added a new feature called destructuring, where you can take an object and you can basically take all the properties out and assign them to a variable. So the difference here is, okay, we're assigning the object Luke, right? We want to get the occupation. We absolutely can, right here. And this would be, our normal, how we would get the variables out, right? What we can also do is write this almost like reverse object syntax, where you have const, you have the curly braces like it's an object, and then you have the names of the properties. Now note that these have to match these names exactly. And when you write it like this, what it does is creates two variables, a variable occupation and a variable father. Very similar to how these work. It's basically just writing this in a shorter syntax, right? And you just set it equal to the object that you're destructuring, and then you have them as variables, just through magic, basically. It's a really rad feature. So let me go ahead and run this in Node. So you can see Jedi and Anakin are pulled out as separate variables right here, just like if they were written this way. And that's effectively all there is to destructuring. Now say we had another variable occupation. And we're like, oh, well, we don't want to override this variable. It's a constant. This might cause problems. As you can see, occupation has already been declared, so it's probably going to explode. But I have this occupation, and I wanted to destructure this object, right? Well, thankfully, they've accounted for that. Like so. Which looks, again, kind of like the object syntax as well. But what we're saying is the occupation property in the parent object is now called Jedi occupation. And so if I console log this, I have all three. So it's just a really nice terse way to pull stuff out of an object, as you can see. Any questions on that object destructuring? I suppose I'll do one more layer just to show you another example. So we have the Jedi, we have Father. Oops. What if we have powers? This is another object. Lightning, right? And we'll just say that they have some power associated with them. Something like this. Something stupid. So they have this powers object that's nested inside of the Luke object, right? He doesn't have these powers. This is Luke, but whatever, you know. He can do whatever he wants. He's a Jedi. So I want to pull powers out. Oops. You can just the same. Then I have the powers. Can I destructure this? Well, let's find out. Yep. So you can also do nested destructuring, but that's unsafe because, let me show you right here. You get an error. Why do we get this error? Because this isn't defined at all. And we're trying to... This is basically saying we guarantee it's defined with these properties, right? Here's a caveat. Just to make it a little... That makes it a little more confusing. But it's something that you should see. So now we only have the lightning powers. What's going to happen? There's going to be an error? There's not. Now it just says it's undefined. Powers is defined, but the property inside is not. Now remember, objects can have any properties. Doesn't matter what it is, and they can be added dynamically. However, if you're trying to pull properties off of an object that does not exist, so say powers comes back as undefined, what you're saying is I guarantee powers is there and we can destructure it with these properties, but powers is undefined. So it's trying to destructure an undefined object, and that's why that particular example explodes. But this one doesn't, just gives you an undefined. So it's not something that you should do generally, where you have a nested object and destructure that as well, unless you can guarantee that that nested object is not going to be undefined, which is a hard guarantee to make in JavaScript. Pretty much impossible, honestly. Can I slack this? Yeah, I'll slack it when we're done with the full example. These are just objects. We're going to go into arrays now. So any questions on the object destructuring? We're going to move to the arrays, and then if you come up with questions, you can ask them. So arrays can be destructured in a similar way. We have this array that, for some reason, they keep using var in these examples, and I have a feeling we're going to see this... We're going to see this a lot. So we can take out first, second, and third, you know, or first, second, and all the others, like normal, right? Where you just pull them out by index, and then you can do a slice to get the rest if you really wanted to. We can't reassign the racers because I just changed it to const, but that's okay. I guess I'll make it a let. Damn this example. There's this is a weird order that they gave this in. I'm going to comment that out for now. We can pull them out with a similar kind of destructuring. So we have Anakin, Gascano, Alderito. You can pull them out the same way as this, kind of like the objects, right? Where we have a first, second, and other by index. Or you can basically say, have this like reverse array syntax on the left-hand side. We could say, here's the first element, here's the second element, and here are all the other elements, right? And I'll explain this operator in a moment. Here, excuse me, here are all the other elements. And then if we console log them out, it would work just fine. Oh, it didn't. Oh, that's why. So we have the first one, Anakin, second one, Gascano, and then all the rest in the exact same way.
Can you make those variable names anything, or does it have to be first, second? Oh, okay, so it wouldn't matter. It just knows the position it is.
It knows the position, exactly. This is like a reference by index. So if you know how many are in there, so if you knew that there was always 5, you could actually do A, B, C, D, E, or whatever you needed to name them, right? This is special right here because we have these 3 dots, and this is called the spread operator. So what does this operator do? Now this stuff's all pretty new to us. So, okay, well, the spread operator, what it allows you to do is you're spreading the values of the array. And what that means is everything in this array is going to be broken out like it was individual elements, kind of in a new array form, right? So what you're saying is we want this new version of racers to include every element in the original erasers, and then we're also going to add Sebulba. So if I console log racers right here, it's going to be the same stuff as the first one, but now with Sebulba as well added in. As you can see right here. So the spread operator is a way that you can take stuff out of an array and put it into a new array really, really easily. So what's happening in this last example is we're getting the first element, the second element, and we don't know how many are actually here, but we know that there's at least 2. And then we'll just get the rest. And this spread on the left-hand side is basically saying put the rest of the elements inside the others variable. Sometimes you'll see it like this. Actually, a lot of times you'll see it like that. That's a pretty common naming, rest. Because it's the rest of the stuff. Console log it. You'll see the A and B are the first 2 elements. And then this last one are the rest of the elements from the array. So, spread operator, rest operator, sometimes people call it, but it's called the spread operator. So this one's a little bit more confusing here, but I'm about to show you what you can do with objects too. Any questions on array destructuring and array spreading? So that you can imagine this is really nice for copying an array, right? Because we have racers. Say I want const new racers. This is a totally new array. It's no longer related to racers, but if I console log it, let me declutter the output. Actually, even better. Let's do racers.push new racer. So now what I'm doing is I'm spreading all of the racers in the racers array to new racers, pushing a new racer to the racers array, and I'm going to console log the difference between the 2. So you might think intuitively that they'd be the same, but the reality is the new racer is only in the original racers array, and that new racers array is a totally different array altogether with the elements copied over. So that's basically what spread is for like copying stuff really quickly, right? Copy all the elements, make a change without affecting the original. Questions on spreading and array destructuring?
When you push that to the new racers, you can still call them out just like you would a regular array, so you call it 0 and the same 0 as racer.
Good question. Let me get rid of this console log because it's kind of confusing. I'm gonna do some template literals there just to make it easier. So let's console.log racers 0. Let's console.log new racers 0. And then we're going to do racers.0 so here's what we're doing. We are spreading the original racers to the new racers array. We're adding a new racer, which is going to be me, because I am now a pod racer, to the racers array. I'm going to console log both arrays so you can see the difference between the two. Then we'll console log just the first element, show you that they're the same. I'm going to change the first element in racers, and then we'll see if they're the same. Oh. They're not. They're not at all. So here's the original racers. Here's the new racers. Here's the first element, both of them. I changed it in the racer array and then console log them both out again, and only the racers array has the change. Now, it gets more complicated. If those elements in the first array were objects, and I changed the object to have a new property or something, it would be in both, because objects are passed by a reference. Just like with the const, you can set a const to an object and change the properties of the object. If you spread it into an array, you still have the same references, because you're spreading the references to the objects, but you're not actually spreading the objects. So if we change that, I'm just going to do this with a couple. So we have name, Anakin. So let's just add Bulba, right? And then we're going to go ahead and not worry about that. We're going to spread the racers here. I'm going to push name Carson Howard here. We'll see both racers, and hopefully it prints them all. It might have a problem. Now this is an object, so we have to change its name, and let's see what happens. So these are objects, they're printed, that's fine, but we can see that at least there's a difference in the number. But here, I changed it in one of the arrays, but both of them are different, because the objects in the array are reference. They're passed by reference. So I'm actually changing the object's properties, but not the reference to the object. That's the same, right? So if I, for some reason, change the reference to the object in index 0, we've got a different story. This one, it gets a little more into the weeds, but it's an important distinction because you might end up spreading a bunch of objects and not realize why you're changing both.
You have to reference the second array to get the different one.
No, I am referencing the second array. But it's the same object, see?
Oh, right.
So, okay, now I have an object. Obviously, you can't just pass the objects around and expect them to be different. But what if I want to copy an object really quickly, right? So what if I have this, and I actually set it to, this is going to get crazy. And now they're different. Because I actually am changing the entire reference to a new object. Now I'm also doing something else. I'm spreading the object and changing the name, which isn't totally necessary here. I can actually just do this, and it's the same. Let me run clear and then run it. But because the object itself at index 0 has changed, and now they're different. But before, we were sharing the same reference, so it was the same object. It's a very important distinction that will come to bite you if you don't understand it. It's an easy bug to cause. So I showed too this fun little syntax. Well, what possibly could that mean? Let's see. Let's just say he was 10 when he erased. I don't know how old they actually were. Okay, well, I'm creating this new object with the name Anakin, but I'm only changing the name. Notice that I don't have the age anywhere in here, but the final output actually still has Anakin's age, because like arrays, you can spread the properties of an object. So this is a kind of a complex piece of code wrapped up into 3 dots. Because what it looks like is something along these lines. It would be like var Anakin equals racers 0. Anakin var name equals Anakin. Var age equals 10. Anakin equals this. Anakin dot name equals Anakin is a racer. Anakin and king dot age equals age. This is literally what those 3 dots do. It's a lot faster for you to type. Yeah. Most definitely. Or at least this part right here are these curly braces. And the dot 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 says, oh, okay, well, we can actually just do like a Anakin dot age. And this could be like var new Anakin, right? So this is probably closer to what this whole spread thing is actually doing, like this. Now I'll show you too, there's a caveat here as well. If I change the order, oof, didn't actually change it. Because the order that you have them here, this new object, is the order of precedence. Or is the lowest precedence the highest precedence. So what happens is we define the name in the object, and then we spread the old object, which also has a name, so it is the one that wins. And when I have the new name after that, what's happening is we're creating this new object, we're assigning the name, so it's kind of happening like this now, where we are, and a king, jeez. Where it's going like this, dot name, and then it's doing new Anakin dot name equals Anakin is a racer. So this is actually probably closer to what it is if you want to think about the whole thing. So it sets the name first to the original Anakin's name, but then because I have it afterwards, it's overriding it. But if I set the name first, it's then getting overridden with the original Anakin's name. That's kind of the flop between the two. I assume there might be some questions on this. And I assume you might not remember all of the caveats to this syntax. I know I just went pretty deep into it. But we're going to do an exercise where we play with it a bit, and then I'll answer any questions if you can't remember. There's a lot of rules here. But what you really need to remember are the difference between references and values. If these weren't objects, the spread on the array would have been totally cool. But because they're objects, the game completely changes. And that's the thing you got to remember. Objects and arrays are very, very different from numbers, strings, and booleans. Okay? Does anyone have any questions before we start the activity, or do you want to just jump into the activity? 109, student object destruct. Yes. Let me annotate it while you're working.
Teach us arrow functions and then follow the example, which still arrow functions.
Don't ask.
109. Oh, we just put it in there.
Okay, let's go over this example. So, I went pretty in depth on some of the stuff there, but I did forget to go over how these can be used in functions. So this one might have been tough, but some of you might have figured it out. You have these objects here. You can actually destructure them in the function declarations. So one is converted to arrow functions here for some reason. But here, we're destructuring the avatar. So in greet, that would be all of these, right? So these are different avatars. So it just pulls out the different information about them. Then you can console log it out. In this one, we're actually destructuring the avatar in the function declaration itself. So if we know that there's an avatar coming into this function, you can just destructure it right there, and you don't even need a variable for it. You don't need to do it twice. Just destructure them all and use the individual properties. So this is another nice advantage of destructuring, is you can just do it right then and there in the function declaration, and you'll see this a lot. A lot. It's used quite a bit. Now there's obviously some danger here. What if you don't pass in an object? What if you don't pass in all of the different properties? Some will come back as undefined. You may get an explosion. So you got to be careful, right? Because you're making a lot of assumptions. In JavaScript, it's hard to make assumptions. But you can do it. Are there questions on this example? You can see too the avatars already exist like this. And we're adding add avatar takes in a new avatar and just adds it to the array. It creates a new array with the original avatars and the new array and returns that. So add avatars takes the original avatars array instance, adds Borub to it. We have a new array with 3 elements in it, and then we can for each over them with this greet function. Like so. Or you could call greet2. Let me run this. So you can see it added the third one in this greet2 function because that add avatars, because the original avatars array only has these 2. Right? So we call add avatars, we add the third one in, and then when we call greet2, it console logs all 3. Any questions on this example? Why do you need to use object destructuring? You don't. It's just a convenience. It's just a convenience for you to be able to make things easier. I mean, obviously, like with object spreading and stuff, there's a lot of helpfulness to it, right? You don't need to at all, though. Definitely don't need to. We'll see a lot more use for it with React. There's a lot of use for this stuff with React. Because it gets kind of complicated with React. Yes, this is only ES6. Pretty much every modern browser supports this stuff. I'm not doing anything special with Chrome, it's just working, right? Working for all of us, so. Yeah, again, any questions here? TAs will slack out this example for you. Because this is the solved version, but we're going to go ahead and move on. Okay. Alright, so now we get into the precursor stuff to React, using Babel. So there are some interesting things we will need to do with React. First of all, does everyone have Babel installed globally? You should open up your terminal if you haven't done this. npm IG Babel CLI. Oops. Babel CLI. Mine might fail. I might need to run sudo. So if you're on a Mac, you might need to run sudo first. Nope, mine worked. You should have the ability to then type in Babel. Won't really do much. or babel dash dash help and get something like this. Or even babel dash V is a better thing to type. Oh, dash capital V. To get the current version, which should be something along the lines of 6.26. Anyone having trouble installing this? Because your TAs will come around and help you get it installed. We're going to need it. Babel dash capital V. Alright, I'm moving on. If you don't have it installed, you need to tell the TAs. Okay. So, next thing I want to show you that you require Babel to do is the cool new import-export syntax that we get with the latest tools. So Node does not support import and export by default. However, some browsers have started to. I think Chrome has some support for it, somewhat. But for the most part, you need to use some sort of tool like Babel. So I'm going to show you this stuff first, and then I'll kind of explain Babel a little bit to you, what it is. Anyway, before when we were doing Node, we would have these require statements, right? So it'd be like const before obj equals require, and then be slash data slash before obj. This is the functional equivalent to this. Except this is a little bit more intuitive when you're just reading it, like what exactly it means. We're importing the information from before obj. So if we look at what this is, it's effectively just an array. But it too has new keywords. That's the functional equivalent in Node. Export default literally equals module exports. Functionally equivalent. Basically, it means you're only if you require that file, that's what you're gonna get. You don't have to go into it. You're not looking for any named exports. That's just what you're gonna get. This array. Looks like all of these are just arrays. Now in this, it's slightly different. This one has export, but it's exporting a bunch of functions. And that's kind of interesting. And there are even like arrow functions, right? The functional equivalent to this export keyword, where you're just exporting a random function or variable, is this. Create an object, export the object with all of the different functions described in that object. It's just a little bit cleaner because you can do it on each individual line. You don't have to have this module.exports at the end. There's other things with import-export that are nice, but I'm not going to get into them. Just think of them as the functional equivalents to these module.exports and stuff. And that is because of Babel that we get these. In Babel, when we run Babel, and if we were to actually parse this with Babel, the output you would get would look like this with the module exports. I'll show you in a second. We'll be running it against the files. So, assuming I didn't break anything, well, I definitely broke this one. You can see I have this Babel RC, which I'll get into in a moment, and I have some information about Babel in here, but I don't actually have Babel. I'm just going to go ahead and run npm install. There's a tool Babel node that we can use. And we use Babel node instead of node to run the index.js, and what it does is it runs it through the Babel process and then calls node on the Babeled files. So import export, it's Very, very similar to the module exports. Now, one thing, we didn't import this index.js. So if we wanted to do that, oh no, it's right here. So you can see here, we have the object destructuring, where we're literally importing the index.js file from utils. So this is similar to const with all those methods, right? It'd be like a const object. Those are the functional equivalents. Or right? The old school functional equivalent of how we were doing it. But now you can use destructuring to destructure out of your requires, and then you can use import and from when we have Babel installed to just destructure them with the import from statement. So why am I showing you this? Because with React you have to use import and export. Because with React you're going to see this destructuring of functions a lot. Destructuring of classes, destructuring of a bunch of stuff. You're going to see it all over the place in React and when you're dealing with Babel. So the import export, we're going to do an activity in a moment, but I want to take a second to explain Babel a little bit more to you. So there's a babeljs.io you can go to if you'd like. Babel is what's called a transpiler. Now it says Babel is a JavaScript compiler right there, but it's actually what's called a transpiler. They're pretty much the same thing. A compiler is generally something that compiles to like machine code, and a transpiler is something that transpiles from one language to another. And so what we do is we are using Babel to take this new syntax, the import exports and all these other cool features that we don't have in Node, and turn them into functional equivalents in what we do have in Node. For instance, an import export does not exist in Node, but if we run it with Babel, Babel will transpile it into module exports and requires for you. It does it for you. It's pretty neat. And so we need Babel to get a lot of these features to even use things like React in a sane way. Without it, we wouldn't even be able to use React because React has all kinds of special syntax that doesn't even exist and never will in JavaScript. So Babel is our transpiler, and there's a lot you can look at here. There are these docs. You can go ahead and go through these docs if you want. There's a whole lot to it. There are things called presets, which you use to define what kind of features you want to enable. If we go back to this example, we have this BabelRC. You always need this BabelRC, .babelrc, right? And this is just a JSON file that has this presets array, where you can define what the presets are, and the presets are telling us what our environment's going to look like when we transpile. What can we use in our Babel code that can be effectively transpiled to JavaScript? So if we don't have our presets set properly, we won't be able to use import and export because Babel won't know that it needs to transpile those for us. You can look in our package.json. We have them here. The presets are installed, babel-preset- whatever one you want. In case we have env and stage 2. We specify them in the BabelRC, and then Babel node works fine. So how do we run it? Again, when we have a file that requires babbling, and you have Babel node or Babel installed globally with the Babel CLI, you can just run Babel node instead of node on your file that needs to be babbled. Right? It needs to go through that transpilation process. There's a lot to Babel, and I'm really only scratching the surface, and this is a very cursory look at Babel and how it works. But we need it. We're going to have to use it. There's even a Babel REPL that you can use if you want to, in VS Code, if you want to test like what versions your code needs to be properly transpiled. So if you just look up in the extensions VS Code-Babel-REPL, and then you can read the example of how to use it. Important thing to know is JavaScript has a very turbulent history. And the thing about it is every web browser implements JavaScript differently. It's just a fact of the matter. And not every browser then has the same features. or is up to date with the latest features. And so tools like Babel basically allow us to write a consistent JavaScript across all browsers and transpile it to whatever that browser supports. So the minimum version that all browsers support, which is usually ES 2015, which is the JavaScript we've been writing so far. We don't have object destructuring, we don't have all this cool stuff we've been going over today, but Babel takes care of that for us.
Do we need a tool like Webpack for Babel?
Webpack will do babbling for you, but you need to add plugins to it. We'll get into that with React a little bit. But yes, there are other tools that use Babel to do that process for you. In Gulp, you can do it, you know, so you can have a Gulp phase to run Babel and then do the rest of your stuff, like build Sass and all that. So I know this is a very cursory look at what Babel is and how to use it. Extremely cursory. There's two things you're going to have to know for right now for our next few examples. One, npm install, because your package.json is going to have some environments. Two, make sure you have a Babel RC with those same environments specified. Three, we're no longer going to be using Node on the examples for today. We're going to use Babel Node. Those are the three things we need to remember today until we spend more time with Babel and we start to understand exactly what's going on. Before we move on to our next example, do you guys have any questions? Has anyone had a trouble installing Babel? Because tell us now. Andy, you've had some trouble? Or do you get it?
I don't have trouble. I'm just wondering, like, I've been using NodeMon. Is Babel Node going to talk to the server as much as NodeMon does?
Nope, and you won't be able to use them without extra plugins. You won't be able to use them together. Babel Node might have an extra feature for doing something like NodeMon where it restarts it, but NodeMon itself works with just vanilla Node. So there's things called registers you can download, and eventually, if we're working with those, I'll show you. But with the React stuff we do, it'll all be in the browser, and it will have hot reloading built in. So you won't have to worry about that. Okay, let's go ahead and move on to activity.
I had a question.
Yes.
So in the index.js file, those variables after import, can those be named whatever we want, or do they have to match the file they're referring to?
I see. These?
Yeah, the top three specifically.
Oh, these ones right here can... that's a great question. These three can be named whatever you want.
They just happen to match.
They happen to match, but because there's not a named export coming out of it, that's a great question. Something I forgot to bring up. So these ones have what's called default exports, right? So that's the same as module.exports equals. And when we do that, there's not a name associated with what we're exporting. But when we export something like from these utils with an explicit name, you have named exports, and yes, they have to have the same name. You can rename them with this as keyword. Not quite the same as destructuring, slightly different, but you can rename them, but they have to be referenced originally by their name that they're exported as. So that's a great question. Export default doesn't have a name. You do not have to give it an explicit name in your import. You can name it whatever you want. It'll work just fine. People usually give them the same name, if that makes sense. Just like when we require FS. We can call FS whatever we want, right? We usually call it FS because if we called it, you know, HTTP, it'd probably piss a lot of people off. So that's just a courtesy, right? But you don't need to. Any other questions? Okay, activity 112. We're gonna try to get the module syntax to build. So you're gonna need Babel. Whoops. And just so you can see these two files while you're working on this exercise, this is again a default export. This is a named export. So here they both are in front of you while you're working.
Are we on 11?
112. Okay, let's go ahead and go over this. I know that wasn't a lot of time, but we got to move on. So what we have here is the sprite logger, spirit logger, and we need to add some imports and exports to this project, right? So we already have our presets defined in our package.json and in the BabelRC. So if we just do an npm install on that folder, we'll be good there. So the first thing are the sprites. We need to export all of these as named exports. All you need to do is add the keyword export in front of the const. Now they're named the same name as the variable, right? So this is named star, this is named stick figure, this is named happy face. What was that? There does not have to be a default in a file. There only needs to be an export of some kind. But this one, we want to export default the sprite logger function. So there's two ways we can do it. We can do export default sprite logger, like so, or you could just replace this with export default, which also works. It doesn't have a name. It's anonymous. Do whatever you want with it, which is a little easier. Now in here, we need to import the sprite logger, and we need to import the sprites, which is going to be happy face, star, and stick figure. Once they're imported, we can use our Babel node to run index.js, and we get some sprites that print. Do. Amazing. Look at that. It's brilliant. Any questions on this example? We will Slack out the solution so you can look at it as a reference, because we got to move pretty fast. We're actually not even going to get to the last activity today, so I'm going to have to just give you the solution and you can do it in your free time. Because we have one more important concept to talk about. Okay, so the last major concept in ES6 that was a big breakthrough for JavaScript are classes. So you may remember about, I don't know, 10 weeks ago at this point, 8 weeks ago at this point, I don't know, it's been a while, when we talked about constructor functions and these weird prototype things that you have to add functions to, and using new and all kinds of weird stuff that was just weird. Very hard to understand the prototype inheritance in JavaScript. Now, technically, classes are in Node proper. You can use them without Babel, but they were originally injected with Babel. And they're pretty much in every browser now, too. But we have the ability to use a class keyword and specify the name of the class, and then define a class almost like we would in another more traditional object-oriented language. So before, what we'd have to do if we wanted a new class is we do function vehicle, right? And it would look something like this. And then if we wanted to add a property to it, we do something like this. That's okay, I'm not gonna run this. So this right here is like the original way that we'd make classes, right? We'd have a constructor function, and if you wanted to create a new vehicle, and then you could pass in the make and the acceleration. Right? We remember that? Well, someone said, well, that's stupid. Prototype doesn't make sense. I hate all of this. And they came up with this class model, where you type class vehicle. Your constructor function is effectively the same. The only difference is you don't have to name it anything other than constructor as a special name. Constructor. Now we know it's the constructor. And your functions are just named functions directly on the class. So you just do the name of the function almost like it's a property on an object, right? Give it some parentheses, and you write your function. It's just kind of like baked into this context. And the same things all work. We have a vehicle, we can do new vehicle, call, accelerate, and brake. And then right here, here's the but I was just typing, I guess I could have uncommented it. This is like the old way that we'd have to do it. Let's look at another example. Pokemon. Pokemon as a constructor takes a name and is sleepy. We set him equal to this, and then we define the functions. Notice that there are no commas between the functions. There's no function keyword. It's just name, parentheses. There's no arrow. You cannot do arrow functions like this. You can use arrow functions in class functions, but there's a slightly different syntax. However, normally you don't need to. Normally you don't want to. That's not the point of the class. Sometimes you do, and people argue about it, but they're just being stupid. Just the name, some parentheses, the regular function declaration, right? And then inside of that, your function. You can use this to your heart's content, because this, in this case, is going to be that of the class. So this in the constructor and this in these functions are all the same this. Now we have a Pikachu. There's another thing we can do. We have these classes, you can actually define like a default class. So here's Pikachu, say name and wake up. And you can use this keyword extends right here. So Pikachu extends Pokemon. Notice it takes in a name and is sleepy, but it also takes in a parameter is hungry on the constructor, and in this case it calls this super keyword inside the constructor. What's happening here is we're actually calling the constructor of Pokemon. Name and is sleepy. We're passing in name and is sleepy. Because it extends Pokemon, we need to also call the constructor of Pokemon inside the constructor of Pikachu. Guaranteed, you gotta do it. And then we can add functions to it. Ask, mood, feed. Now Pikachu has 4 functions. Say name, feed, wake up, and ask about mood. Wake up and say name are part of the Pokemon class. They're not explicitly defined in Pikachu. But Pikachu can still get to them. Right? Because Pikachu extends the Pokemon class. So it's adding more functionality to the Pokemon. If you don't call the Pokemon's constructor, you don't have that functionality and there's no point to extend it. So it's just a nice, clean way to be able to do classes. Full-fledged classes in a lot of ways.
Can you extend from multiple? Like Pokemon and monster?
Good question. No, you cannot. One at a time. However, you could extend Pikachu. You could have Pokemon and extend Pokemon with Monster, then extend Pikachu from Monster. Right? So you could do a chain in that way, but you can only extend from one at a time. And we can prove that.
Can you do template functions in this?
What do you mean?
Like interfaces?
No. These are both. There are in TypeScript, but that's different. So we can do monster call, console log, I am so if we could extend both, it'd probably look something like that. But we can't do that. That's invalid syntax. Or maybe it'd be another extends. Also can't do that. It's invalid. So there's just no way to do it in JavaScript. But, you know, we could extend Pokemon here. And then we could extend Monster in Pikachu if we wanted to. But you can't extend 2 at the same time. That's a really good question.
So this is just equivalent to Spider Titans.
Yes, single class inheritance. It's sort of equivalent. Under the hood, it's still using the prototype model, which is not equivalent. But you can view it that way from a high level, yes. And that's how it's used. Questions on classes? Cool. Let's go ahead to activity 114, and you're going to convert old school constructors to classes.
Yeah, something about Sprite.
Uh-huh.
So in your Sprite logger, you export default, and then you exported the anonymous function that takes a sprite. But then in the index, we're actually calling the Sprite logger.
You can name it whatever you want. It's a default export. You can name it A. Rename it A and change the sprite logger calls to A, and it'll still work.
Oh, because when we import it, we're naming it Sprite logger.
Yes.
Right. That's the part of it. I was like, how are you calling sprite logger if now it's anonymous? I thought you were calling it.
Right. That's the confusing thing about the examples. They give them the same name. They shouldn't. Because it makes you think that they need to have it.
Yeah.
Is this class specific to Babel the way it's formatted, or is it?
Nope. So what tools like Babel do is they actually go to the specification that's being drafted for these things, and they implement them in the same way the specification recommends. But they do it before the browsers do, because it's faster for them. Because with the browsers, there's a lot of work to get this stuff in the browser, and to make sure that everyone on the ECMAScript committee can, agrees and stuff like that. So in the case of classes, since they've already been introduced in all the browsers and all the versions of Node and stuff, it's the same.
So we don't have to use Babel, we can use Node.
Mm-hmm. You can use Node for classes, yes. And for arrow functions, and for object and array spreading.
So this is just raw ES6.
Well, all of it is. But with Node, some of these features are available, but some aren't. Like imports and exports are not, and they probably never will be in Node. So you need Babel. But in the browser, you need Babel for a lot of this stuff. Depending on what browser it is. Like IE11 has none of these. So okay, since we only have 5 minutes left in class, I'm going to go over this. there's one more exercise that we'll slack out the solution to, exercise 115. It's a longer exercise, it's supposed to take 20 minutes. It's a bunch of these things all culminated into one final activity. So I recommend you try to do it at home because it's going to cement these things. But we aren't going to be able to get to it here, of course. Anyway, this is what we started with. We have our digital pal, that's just a function. We have all these functions off the prototype that we're allowed to call, and then you can see we use new digital pal and we call all these functions. But we don't need to do all the weird prototype stuff that we're used to. It's a pain, it's hard to remember the rules. So we can convert it to a nice fancy class. First thing you do is create your class, right, with the same name. You can go ahead and open it up, and then you can just start taking your functions. What I'll do is like start with the first one, you know, feed. Copy it over. Get rid of this noise. Get rid of this, right? You're also going to need your constructor. Okay, I can copy that over. Easy enough. Remember, the constructor is special because now it's named constructor. So now we have our constructor in feed. Right? Do the same thing. I want sleep. I'm going to copy sleep. No commas or nothing. I go ahead and get rid of the equals function keyword. Make sure I don't have the semicolon at the end. And we're good. And that's really all there is to it right now when you have the base class that you can copy over, right? And you end up with a nice looking thing like this. It's all contained in this one class. You call up your digital pal. Should work okay. I must have called it.
Yeah, if you call it twice, it changes it. Or 3 times. Every time.
Oh, I didn't save the file. That's why. Whoops. Save your files. Notice I'm using Node here because it actually works in Node and Babel Node. Classes are in Node. But I can also do Babel Node. Oh, I didn't do npm install. I got it, Garrett. I got it. Works the same. Any questions? Not in normal JavaScript, no. Where you initialize it like this? We'll come help you. Any other questions? Alright, we're going to slack out the solution to this. We're going to slack out the solution to activity 15. I recommend, again, you do it before your next class. So Monday, Wednesday, you guys should do it tonight or tomorrow. Because it's only going to help you remember these things. And we're plunging into React, and there's a lot today. And you're just pretty much expected to know it. Because we're going to go into a whole lot more new syntax and new things. It's going to be a lot. You remember that feeling when we first started Node and everyone was like, and then they just kind of walked out of class? Or jQuery, and everyone's like, ah, and then they just kind of walked out of class. You're about to get that again. So, here it comes. Yeah. So, class is over. Go nuts.
Is there a React book you will recommend?
Nope. Read the docs.